Okay, welcome back to the last lesson in chapter 14. We're going to finish up section 14.3. Today we're going to prove or verify trig identities. That's our target for today. If you did not write these identities down yesterday, you're going to want them because we're going to be using them today. It's very similar to simplifying what we're going to do. Which you'll see here in a minute. So if you didn't get these down, get them down, pause this, and get them down right now. Okay, so verifying a trig identity. Basically, verifying means you work one side of the equation to get the other side of the equation. You can pick the right side and work back to the left, or pick the left and work to the right. For me, usually it's easier to work for the more spread out or more complicated one, simplifying it down to the smaller expression. It's basically just like simplifying yesterday, except you already know what your answer is going to be. I know that secant of theta times 1 over cosine of theta minus tangent of theta times cotangent of theta has to equal 1 minus cosine squared of theta over 1 minus sine squared of theta. Just have to figure out how to get there. I'm going to use identities I had yesterday. So if we have I'm going to choose to work the left side to the right side, I should say. So secant of theta times 1 over cosine of theta minus tangent of theta times cotangent of theta. So is there anything we can swap out of there? Well, I know that 1 over cosine of theta, that is just the same thing as secant of theta. So I'm going to swap that out. They're reciprocals of each other, so I can take 1 over cosine out and put secant in. We haven't changed yet. Tangent of theta times cotangent of theta, well, that's sine over cosine. Oops. Sine over cosine. Times cosine over sine. And those just happen to cancel out. Secant times secant is secant squared. And then we have minus 1. Well, secant squared of theta, if we look at our Pythagorean identities, that can be written as 1 plus the tangent squared of theta minus 1, which is tangent squared. Remember, we're trying to get, if this was simplifying, we'd be done, right? This is simplified. We're trying to make sure that it equals 1 minus cosine of squared over 1 minus sine squared. So we can't just stop here where we normally want to simplify. We have to keep going. The tangent squared of theta, well, that can be rewritten as sine over cosine. And if we look at the Pythagorean identity, sine squared plus cosine squared equals 1, I can rewrite that, and sine squared is 1 minus the cosine of theta squared. And cosine can be rewritten as 1 minus the sine of theta squared. And look, lo and behold, we have what we wanted. We've worked the left side and proved that it equals the right side. We'll put this little triangle down, this little square, diamond, and that tells us that we're finished. But that's what verifying is. We simplify one side, work it out so that it ends up at the other side of the equation. Okay, here's another one. Cosine squared of negative x over cotangent squared of x. We want to prove that that equals the sine squared of x. Obviously, the left side looks more complicated than the right side. So the way I do it, it is possible to work the other way, but the way I like to do it is I like to work the more complicated side to the simplified side. So cosine squared of negative x, if we want to, what that really means is the cosine of x, negative x, the whole thing squared. But just write it shorthand. This and this are equivalent, okay? These two are equivalent expressions. That's what it means. We just write it on the top for shorthand, so we don't have to have so many parentheses. So if that's what that really means, we can apply the negative angle identity to this. And the cosine of negative x is simply the cosine of x. So this is just the cosine of x squared. over cotangent squared of x plus I. Well, cotangent, we can write that as cosine over sine. When we divide by a fraction, it's the same as flipping the bottom fraction and multiplying. So we're going to flip cosine of x over sine of x, and we're going to multiply sine of x over cosine of x times cosine of x. Notice the cosines, they cancel out. Oops, I write the squares all the way through there. I did. Let's write the squares in there. So then cosine over sine. Well, still, cosine squared over cosine squared, they cancel out. Then we get sine squared of x, which is what we wanted to prove. We did. We work one side, finish up the other side, and we're done. This is just the same problem written twice. I don't know why. Same thing. Cosine of x times cosecant of x times tangent of x equals 1. Obviously, the left side looks more complicated to me, so we're gonna try and simplify this to equal 1. Cosine is really 1 over the secant of x times cosecant is really 1 over sine of x. Tangent is sine over cosine. The sines cancel out, and I end up with 1 over secant of x times 1 over cosine of x. Well, we changed its cosine of x at the beginning just because we could change it with reciprocal functions. And now we're seeing maybe I wanted to leave it alone. So if I let changing it back to cosine of x times 1 over cosine of x, I can see the cosines cancel, and I end up with 1. So sometimes you're going to change things, and you realize, oh, I didn't really want to change it, I want to change it back. Okay, last one for today. Cosecant squared of x times 1 minus sine squared of x equals cotangent squared of x. Well, if you look at this problem, when we think of the Pythagorean identity sine squared plus cosine squared equals 1. If I subtract sine squared from both sides of that, I now have cosine squared of theta equals 1 sine squared of theta. So I can take this out and put cosine squared of theta in. So you can manipulate these identities as long as you move things correctly, legally, mathematically. You can manipulate these identities however you like. 1 minus sine squared is just cosine squared of theta. Or x, I guess we're using x in this one. Cosecant squared times cosine squared. Well, cosecant squared, that's 1 over sine, which times cosine squared. Remember, we want to prove this is cotangent. I multiply these together, I get the ratio of cosine squared over sine squared, which by definition, cosine divided by sine is cotangent. Since they're squared, it's going to be cotangent squared of, should keep changing this to theta, should have done x for this problem. Don't really big deal, just be consistent with the variables up there. And we've proven that one as well. Well, that's it. I think we've accomplished our goal. We verified trig identities of all sorts and sizes or types. We'll have more to do in class tomorrow. Bring your notes with you so I can remember them. We'll see you then.